Hey, hey, hey from West Virginia. Or somewhere, I don't know. But what I do know is joke of the day, and I know you're ready and waiting, so let's get to it. You know, I have this book, and it fell on my head, but I've only got my shelf to blame. Because it was up on a shelf. So it hit me like, oh golly. Okay. Well, let's get into something that is not such a complicated thing like this silly joke that I've got for today. Let's get into complex numbers. Now, complex numbers sound complicated because it's called complex numbers, but actually they are not difficult at all. Because what happens with the complex numbers, you've got what's called a standard form. And you've got this real part here and this imaginary part here. It's what I call a mathematical mullet. You remember, or you don't remember, but back in the 80s we had these really cool haircuts where we had that business in the front, party in the back. We had the short part in the front, that was the business in the front. We had the long hair in the back, and that was the party in the back, and we thought we were so cool with our mullets. But your complex number is your mathematical mullet, because here's that business in the front, here's that party in the back. And this is the standard form for your complex number. Now, we are used to real numbers. We're used to real numbers where we've got, say, for instance, a 2 or a -2, or maybe a 1/2, or maybe we've got a square root of 2. All of these are real numbers because they have no imaginary parts to them. So when this imaginary part is existing by itself, in other words, when that a is 0 and this part is gone, you simply have an imaginary number. So in terms of those sets of numbers that I talked about a long time ago in one of the first videos, remember all those boxes, and I was putting things together and creating the sets of numbers. We started with our natural numbers, which are the ones that occur naturally in nature. Those counting numbers, 1, 2, 3, 4, 5, and so on, the natural numbers. And then remember we said if we put one number with it, that would be a 0. And since we put the 0 with those natural numbers, that creates the whole numbers. And then we said if we take those natural numbers and we flip them over to their negative counterparts, that creates all the negative numbers, your -1, your -2, your -3, and so on and so forth. So we've got our positive integers, our negative integers, and that 0, that creates the set of integers. But we said when we throw those fractions and decimals in there, that creates the rational numbers. Not rational do, but rational numbers, and rational means can be written as a fraction. And then we said, okay, it's either rational and it can be written as a fraction, or it's irrational and it cannot be written as a fraction. It cannot be both ways. And remember those red boxes that did not fit inside of each other. Remember, all the other boxes fit inside of each other. And so building up from natural numbers to whole numbers to integers to rational numbers, those all fit inside of each other, building up to the rational numbers. It's either rational or irrational. But we said when we put all those together, that was the set of real numbers. And we said for our purposes at that point in time, that was everything we could think of. It's either irrational or it's rational. But that's all the real numbers. Well, now, when we throw these imaginary parts in there, suddenly we expand our real numbers, and we now have real numbers and imaginary numbers. And when we put those two together, that creates the set of complex numbers. So the set of complex numbers is legitimately, really, literally all the numbers that are out there. And when you have all those complex numbers, you can separate them out into the imaginary numbers, which is just these, or you can separate them out into those real numbers, and those real numbers can now be separated out into rational or irrational, and the rationals can be separated down from there. So this set of complex numbers is all the numbers that exist. And like I said, if you put it in standard form, there's your mathematical mullet with that business in the front, the party in the back, real part in the front, imaginary part in the back. Now, in order for two imaginary numbers, or actually this should say complex numbers, my apologies, in order for two complex numbers to be equal, this to me feels like common sense. But it's always mentioned, so I will mention it here. So I've got a complex number here, a plus bi, in standard form, the mathematical mullet. I've got another complex number, c plus di, in standard form in that mathematical mullet. These two are going to be equal if and only if, and it makes sense. If the real parts are the same, and the a and the c are the same, And if the imaginary parts are the same, and if the B and the D are the same, then these two complex numbers are going to be equal to each other. If the real parts are the same and the imaginary parts are the same, then the complex numbers can be said that they are equal. So hopefully I hope this helps with the idea of just simply what a complex number is and what the standard form looks like, your mathematical mullet. And the next videos are going to describe how to add and subtract your complex numbers, how to multiply your complex numbers, and how to divide your complex numbers. I hope that helps. Have a great day.